Okay, we're in section 15 of the notes now, and it says, rational expressions. The rational expressions are going to be given is going to be basically a ratio. That's what they say, rational, a ratio of two polynomial. We'll go through this. It's a short lecture. And then after the short lecture, we'll go through examples, which takes more time to get through. But we have a technique for this that we'd like you to follow, right? Now, granted, it's the same technique that you were told in grade school for reducing fractions, but you may not see it the same, all right? But it's really the same technique. What's that technique? Basically revolves upon factoring both numerator and denominator, and then canceling factors from both the numerator and denominator that are identical. And we'll go through examples, all right? Certainly related to this is going to be multiplication and division. I want to warn you about this. At this point, they're really not asking you to multiply or divide. They're basically asking you to reduce, all right? We'll get to examples. And let's start with the lecture first, though. And the lecture is going to be short, all right? And we'll go through that one step at a time. All right, so I'm going to another share with you. And give me one moment to do so. All right, so let's talk about one step at a time and what we'd like you to do, all right? Now, certainly I realize that, certainly if you think back to grade school, if you can remember that, and your teacher gave you a problem like 14 over 21, I'll write this down for you. You might have done something like this. You might have said, oh, gee, what are the factors common between 14 and 21? You thought about it in your head and you said, oh, well, 7 is, and then you did something like this over here. You said 7 goes into 14 twice, and it goes into 21 3 times, and then you said, oh, the answer is 2/3. And that's fine if you did that. All right. Again, I want to point out what we did. We found a factor common between 14 and 21. So the factor we found in common was 7. All right. Now I'm going to claim there's nothing wrong with that. I mean, if you did that and you remember doing that, that's fine. The answer is 2/3 as specified over here. My claim over here, though, the key here is recognizing what those factors are. All right. Recognizing the factors. And the way we'd like you to do it is we'd like you just simply to factor the number 14. Let me put out what I mean by that. Factor the number 14 into its factors. When we say factors, we're talking about its prime factors, 2 and 7. And you would factor the number 21 into its two factors and their prime factors, 3 and 7. Then what we recommend you do, and again, this seems like a crazy long process for a lot of students, we're going to divide it into a multiplication problem. All right, what's that going to be? Well, on top, it's 2 times 7, and on the bottom, it's 3 times 7. And then what do you notice over here? 7 divided by 7 is 1. And you get 2/3 times 1. What do you get 2/3? Same thing. I got to be honest with you, what you did over here is fine. If that's what you did, that's fine. It's still going to be 2/3, right? The problem about this over here is a lot of students don't really understand the process. So we want to enforce what we want you to do. And what we want you to do is factor, factor, factor. Let me go through that for you. So you're going to see a fraction here, and this is a fraction. There's a top. This is the numerator. You're going to factor that numerator, right? And that factors to x plus 4 times x plus 4, because x times x is x squared. 4x and 4x is 8x, and 4 times 4 is 16. And you're going to factor the denominator, and that factors as well. And what do you get over there? Well, you get x times x is x squared. 4 minus 6 is minus 2x. That looks good. And you get minus 24. Then you're going to divide it into 2 separate problems, multiplication problem, with the first factor, x plus 4 or x minus 6. I clearly see that. And the second factor, x plus 4 or x plus 4. You should recognize that the second factor, x plus 4 or x plus 4, is actually numerically 1. All right? That's why I wrote this over here. So what do we get? X plus 4 over x minus 6 times 1, going to get x plus 4 over x minus 6. Now, I got to be honest with you. I think a lot of students said, that's way too much writing for me. So I want to go through the next procedure I did. The next procedure I did is I took this part here, and I just simply copied it down. And this is what a lot of students will do now. They'll put crosses through this, like this. I want to point out what these crosses mean. They actually mean 1. And then we say, oh, 1 times x plus 4 is x plus 4, and 1 times x minus 6 is x minus 6. All right. Last but not least, I can't say they're going to try to trick you, but you can be confronted with words like multiply and divide. I don't think you want to multiply and divide at this stage of the game. What you want to do is you have a multiplication problem, it's already factored. If you have a division problem, though, you want to write it as a multiplication problem as soon as you possibly can. So if you're given a division, you want to write it as a multiplication as fast as possible. All right, so what's it going to be? It's going to be this thing here, A over B, times the reciprocal of this thing over here. And what's the reciprocal of that, D over C? We will go through examples, right? When we go through those examples, I'm going to point out the key word here in these problems over here is we're looking to reduce how are we going to accomplish that? By factoring. And we're going to factor until we can't factor anymore. Then we're going to look for factors that are identical on top and bottom and cancel them off. Here's the deal, though. They may confuse you on exams or in WebAssign by telling you to multiply or divide. You are to still try to reduce the problem, make it simpler. How do you do that? Write it as a factorization problem, and then we can reduce it. All right. If there's any remaining multiplications that are easy or divisions that are easy, we'll certainly do that. Thank you.